Suppose you exert a force of 180 Newton tangential to a 0.280 meter radius, 75 kilogram grindstone. Grindstone is like a solid disc. A. What torque is exerted? Alright, given tangential as the force tangential perpendicular to the radius is 180 newtons. What else do we know? We know the mass of the grindstone, 75 kilograms. And it's like a disc, solid disc. A, we are asked to find the torque. And we know that torque is equal to, the torque is equal to F times R. And the radius is given as well. The radius is 0.280 meters. And we know that tau is equal to, or the torque is equal to the force perpendicular times the lever R. In this case, the radius. Plug in the numbers. 180 newtons multiplied by 0.280 meters. That's equal to 50.4 Newton meter. B. What is the angular acceleration assuming negligible opposing friction? So opposing friction is 0. And what we are asked to find is the angular acceleration. And we know that tau is equal to I times alpha. Newton's second law in rotational motion. And this implies that alpha is equal to tau over I. Now the grindstone is like a solid disk, so its moment of inertia is given by half or 1 over 2 mr squared. Therefore this will be equal to 2 tau, and tau is equal to F times R over mr squared. R divided by one of the R's, we're left with 2 times the force divided by mr. So just plug in the number. 2 times 180 newtons divided by the mass, which is given to be 75 kilograms, times R, which is equal to 0.280 meters. That's equal to 17.1 radian. Radian per second squared. C. What is the angular acceleration if there is an opposing frictional force of 20 newtons exerted at 1.50 centimeter from the axis? So friction force is not 0 in this case, and that's going to be 20.0 Newton. And the distance where the friction force is exerted is 1.50 centimeter, which is equal to 0.0150 meter. And what we are asked to find is now the rotational acceleration is differentiated from the first of the acceleration in B by just putting a prime. Alright, so alpha prime is equal to tau net over I. And tau net is equal to tau minus tau due to friction over I. We have calculated tau already, so we can use that one or just plug in the numbers. This is equal to perpendicular times R minus friction force multiplied by the lever arm of friction, divide that by half mr squared. This is equal to 2 into a perpendicular times R minus F times RF divided by mr squared. Alright, 2 times the force exerted, which is 180 newtons, multiplied by the radius of the grindstone, and that's equal to 0.280 meter, minus the friction force 20.0 newton, and its corresponding radius, it's at a radius of 0.0150 meter. Divide that by mass of the grindstone, which is given to be 75 kilograms, multiplied by the radius squared, RF squared, that is equal to the radius of the grindstone. That's going to be 0.280 meter squared. Alpha prime equals to 17.0 radian per second squared.